In this video, we will be discussing how to find the limits of trigonometric functions. Please note the following trigonometric identities. Also, recall the rules where 1 minus cosine x over x is equal to 0 and where sine x over x is equal to 1, for these will be used in evaluating the function.
X all over x as x approaches 0. We notice that the trigonometric function sine x is present in the numerator. We remember the rule of sine x over x is equal to 1. We must manipulate the function for the argument of the numerator to be similar to the denominator inside the parenthesis so that it is clear that the monomial 4 can be factored out. Multiply 5 to the denominator so that the argument of sine, which is 5x, would be similar to the denominator. However, we need to multiply 5 to the numerator as well, so we are not changing the value of the function. We multiply 5 over 5 because this equates to 1. Denominator and the argument in the numerator to be both 5x. Now, it is starting to look more like the rule previously mentioned. However, we notice the presence of 4 and 5, so we need to further manipulate the function. If you can recall the limit law of the limit of a constant multiple of a function, the idea has the same basic principles where we can pull a constant multiple out, or in this case, a monomial of any limit, which is 4 and 5. Now, the trigonometric function follows this rule wherein the argument of sine 5x is similar to the denominator. We can now evaluate the multiplied to 1 because 4 multiplied to 5 equates to 20 and sine 5x all over 5x equates to 1. To the answer, we rewrite the given with its answer. We are asked to find the limit of 5 multiplied to cosine 2x subtracted by 5 all over x. As you may have noticed, the given now deals with the trigonometric function of cosine rather than sine x. We must follow the rule of 1 subtracted by cosine x all over x equates to 1. We must manipulate the function. 5 is multiplied to cosine 2x subtracted by 1. However, we need to manipulate the function for us to have 1 minus cosine 2x to satisfy a portion of the rule, factoring out the negative. As a result, we have negative 5 multiplied to 1 minus cosine 2x. Mentioned limit law of a constant multiple of a function, we can pull the monomial negative 5 out. Faced with the problem of manipulating the function so the argument of the numerator will be similar to the denominator. To remedy this, we multiply 2 over 2, which equates to 1, for the value of the function to remain the same, as well as multiply 2 to the denominator for it to match the argument. Mentioned limit rule, we multiply negative 5 to 2 and multiply that to the limit of 1 minus cosine 2x all over 2x. This now satisfies the rule of 1 minus cosine x all over x, which equates to 0. And now we can move on to evaluate the function. 10 multiplied to 0 because negative 5 multiplied to 2 equates to negative 10, and the limit of 1 minus cosine 2x all over 2x as x approaches 0 equates to 0. Rewrite the given with the answer.
X minus 3 all over sine x as x approaches 0, we notice that there is a trigonometric function of cosine x in the numerator and a trigonometric function of sine x in the denominator. Of sine x over x equals to 1 and 1 minus cosine x all over x equals to 0, we have to manipulate the function and give the trigonometric function in the numerator and the trigonometric function in the denominator their own denominators. Apply the function of 1 over x all over 1 over x. Notice that even though we multiply this, we are not changing the value of the function. since this is equal to 1. We are simply manipulating the function in order to follow the rule. X all over 1 over x has been multiplied to the function. We notice that it's starting to look more like the rules. Factor of 3 cosine x minus 3 all over x has a common term. So we can actually factor out 3, making the numerator 3 multiplied to quantity cosine x minus 1. For the denominator, you can see that it is already similar to the rule mentioned. The argument of sine is similar to its denominator. So we don't have to manipulate it any longer. Constant multiple of a function limit law? Well, the idea is quite similar here. The concept is that we can actually pull a constant multiple out, or in this case, a monomial of any limit, and still be able to find a solution. You will also notice that in the numerator of the function, we switch negative 1 and cosine x, making it look more like the rule. So, now that we've found our constant multiplier, can we evaluate the limit? Since the numerator, negative 1 plus cosine x all over x does not look similar to the rule wherein the numerator is 1 minus cosine x. In order to make it 1 minus cosine x, we simply have to factor out negative 1 from the numerator, making it negative 1 multiplied to quantity 1 minus cosine x. Constant multiple rule, we multiply negative 1 to 3, making it negative 3. Okay, so now that the numerator looks more like the rule and the argument of cosine x is equal to its denominator and the argument of sine x is also equal to its denominator, it is now time to evaluate. Stays as it is while the limit of the function is being evaluated. The numerator, 1 minus cosine x all over x, becomes 0, while the denominator, sine x over x, becomes 1. With 0 in the numerator and 1 in the denominator, it becomes 0. The 0 also becomes 0. Therefore, the limit of 3 cosine x minus 3 all over sine x as x approaches 0 is equal to 0. We write the given with its corresponding answer.
As the example, here we have the limit of 3 over secant x minus 3 all over 7 sine 2x as x approaches 0. Is to factor out the common factors. For the numerator, we factor out 3, which leaves us with 1 over secant x minus 1, and for the denominator, we factor out 7, which leaves us with sine 2x. Limit of a constant multiple of a function limit law. Then, apply the trigonometric identity where 1 over secant x is equal to cosine x and copy the rest of the given, which leaves us with cosine x minus 1 over sine 2x. Arrange the numerator for us to be able to cancel out the numerator by interchanging negative 1 and positive cosine x. The negative sign, and once more apply the limit of a constant multiple of a function limit law, which gives you a negative 3 over 7 times the limit of 1 minus cosine x over sine 2x as x approaches 0. Multiply 1 over x to the numerator and denominator to parallel it to the rule. Gives us 1 minus cosine x over x all over sine 2x over x. Recalling the rule where 1 minus cosine x over x is equal to 0, we will leave the numerator as it is and multiply it by 1. Going to the denominator, we will multiply it with 2 over 2, remembering the rule where sine x over x is equal to 1. Sine 2x, we will multiply 2 to 7, which leaves us with negative 3 over 14 times the limit of 1 minus cosine x over x all over sine 2x over 2x. Line negative 3 over 14 to 0 over 1, which gives us an answer of 0. The limit of 3 over secant x minus 3 all over 7 sine 2x as x approaches 0 is 0.